Jupiter was never supposed to be this powerful. It bends space. It swallows asteroids. It creates storms larger than Earth. And without it, we might not even be here. But what if this giant protector is also hiding something far more dangerous? Jupiter is more massive than all the other planets combined. That statement alone forces a shift in perspective. We often think of the solar system as a balanced family of worlds orbiting the sun, but the mass distribution tells a different story. If you remove Mercury, Venus, Earth, Mars, Saturn, Uranus, and Neptune, and left only Jupiter, you would still retain roughly 70% of the total planetary mass. This is not a minor difference in scale. It is dominance. Jupiter is not simply the largest planet. It is a heavyweight that defines the system's structure. Its gravity does far more than keep its dozens of moons in orbit. Jupiter's immense gravitational pull extends deep into the architecture of the solar system itself. The asteroid belt between Mars and Jupiter, for example, did not become a planet largely because of Jupiter's disruptive influence. Its gravity stirred up the building blocks of potential world, preventing them from coalescing into something larger. What might have been another terrestrial planet became a scattered ring of debris under Jupiter's watch. Comets, too, field authority. As icy bodies travel inward from the outer solar system, Jupiter can capture them, redirect them, or even eject them entirely. Some are flung into new orbits. Others are hurled out of the solar system forever. This gravitational gatekeeping role has profound implications. By deflecting or absorbing potential impactors, Jupiter has likely reduced the frequency of catastrophic collisions in the inner solar system. Even Earth's long-term orbital stability is subtly shaped by this giant's steady gravitational presence. Jupiter is not just a planet sitting quietly in space. It is a gravitational architect, shaping pathways, sculpting debris fields, and influencing trajectories across vast distances. Its mass bends motion itself, creating structure out of chaos. Without Jupiter, the solar system would not simply look different. It would behave differently. Its presence is woven into the stability and evolution of everything that orbits our sun. The Great Red Spot has been raging for more than 350 years, a colossal storm system so vast that it could swallow Earth whole. It has persisted to the rise and fall of empires, through revolutions, technological ages, and the birth of modern science. While our most powerful hurricanes exhaust themselves within days as they lose energy over land or cooler waters, this Jovian tempest continues to churn, defying the intuitive limits we associate with atmospheric systems. On Earth, storms weaken because they collide with continents, mountains, and temperature variations that disrupt their structure. Jupiter offers no such resistance. There is no solid surface to absorb momentum, no landmass to break circulation. Instead, the planet's atmosphere is composed of powerful jet streams arranged in alternating bands, racing in opposite directions at hundreds of kilometers per hour. These opposing flows create shear zones that can both feed and stabilize massive vortices, allowing storms to endure for astonishing lengths of time. The persistence of the Great Red Spot is not merely a curiosity of scale. It reveals how different planetary physics can be when conditions change. Without a rigid crust and with continuous energy rising from below, the storm becomes part of a dynamic system rather than a temporary disturbance. It is sustained by the very forces that would dismantle similar systems on Earth. In that sense, Jupiter does not host storms the way Earth does. It manufactures them differently. And beneath those swirling clouds lies something we cannot observe directly: a deep, fluid interior composed in part metallic hydrogen. Under crushing pressures, hydrogen behaves like an electrically conductive metal, generating immense magnetic fields and contributing to the planet's internal heat. That hidden layer may play a role in sustaining the atmospheric violence above. The Great Red Spot is not just a storm on the surface. It is a visible expression of powerful, unseen processes occurring deep within Jupiter's vast interior. Under the crushing pressures deep inside Jupiter, hydrogen stops behaving like the simple, light gas we know on Earth. It transforms, not metaphorically, not theoretically, but physically, into a state known as metallic hydrogen. In this exotic phase, hydrogen atoms are squeezed so tightly that their electrons move freely, allowing material to conduct electricity like a metal. What begins as the most basic element in the universe becomes something radically different under extreme conditions. This liquid metallic hydrogen is not just a scientific curiosity. It is the engine behind Jupiter's immense magnetic field. As the planet rotates rapidly, once every 10 hours, this electrically conductive layer churns and flows, generating powerful electrical currents. Those currents produce a magnetic field so intense that any spacecraft entering certain regions without heavy radiation shielding will be severely damaged. The radiation belts trapped within that field are far more extreme than anything surrounding Earth. Jupiter's magnetosphere, the vast bubble carved out in space by this magnetic force, is the largest structure in the solar system when measured by volume. It stretches millions of kilometers toward the sun and extends even farther in the opposite direction, forming a massive magnetic tail that can reach beyond the orbit of Saturn. If we could somehow see it from Earth, glowing in visible light, it would appear larger than the moon in our night sky. It is not a subtle feature. It is a colossal, invisible presence dominating interplanetary space. This is not normal planetary behavior. Jupiter is not simply a scaled-up version of Earth or even Saturn. It operates under extreme physics, where matter changes state in ways rarely seen elsewhere, and magnetic forces sculpt enormous regions of space. Liquid metal lightning, invisible but relentless, pulses beneath its clouds. Jupiter is not just a planet. It is a laboratory of cosmic extremes. Many scientists believe Jupiter acts as a cosmic shield for the inner solar system. Its immense gravity pulls in wandering comets and destabilizes dangerous objects that drift too close, either capturing them or slingshotting them away into deep space. In this view, Jupiter functions as a guardian, absorbing impacts that might otherwise threaten Earth. Its sheer size makes it a gravitational gatekeeper, standing between the inner planets and the chaotic debris fields of the outer solar system. The evidence for this protective role became dramatically visible in 1994 when comet Shoemaker-Levy 9 collided with Jupiter. The comet had been torn apart by Jupiter's gravity before impact, forming a chain of fragments that slammed into the planet's atmosphere one after another. The explosion scars were larger than Earth itself. We watched it happen through telescopes. For the first time in modern history, humanity witnessed a planetary collision in real time. Jupiter quite literally took the hit. But the story is more complicated than simple heroism. Some orbital simulations suggest that Jupiter's gravity does not only remove threats, it can also redirect them. Its immense pull can alter the paths of distant objects in ways that send them inward toward the inner solar system. In certain scenarios, Jupiter may increase the number of objects crossing Earth's orbit rather than decrease them. Its gravitational influence is not selective. It reshapes trajectories according to physics, not preference, meaning the same force that may protect us can also send danger our way. Jupiter is both guardian and disruptor, shield and sculptor of risk. It does not choose sides. It simply exerts gravity on everything within reach. So, which role is it truly playing? The answer may be that it plays both, depending on time, circumstance, and celestial alignment. In the cosmic balance of chaos and protection, Jupiter stands not as a hero or villain, but as a powerful architect shaping probabilities across billions of years. If you're fascinated by how giant planets shape our survival, subscribe now, because the deeper we go into the solar system, the stranger it becomes. Jupiter contains more than twice the mass of all the other planets combined, yet never crossed the threshold into stardom. During the early formation of the solar system, it accumulated an enormous amount of gas and material, becoming a dominant gravitational force. But it stopped just short of the critical mass required to ignite sustained nuclear fusion in its core. That missing mass, roughly 80 times its current size, makes the difference between a giant planet and a true star. Why does that matter? Because nuclear fusion is the defining process that powers stars. It requires extreme pressure and temperature at the core, enough to force hydrogen atoms to fuse into helium, releasing vast amounts of energy. Jupiter's interior is hot and compressed, but not enough. It radiates leftover heat from its formation and from slow gravitational contraction, but cannot shine by fusion. It sits on the boundary between planet and star, massive, but not massive enough. Now imagine if Jupiter had grown slightly larger during the chaotic early days of planetary formation. If it had captured more material from the protoplanetary disk, the solar system might have become a binary star system. Two luminous bodies orbiting a shared center mass would have reshaped everything: orbital dynamics, radiation levels, and the stability of inner planets. Earth's orbit might have been destabilized, or the conditions necessary for liquid water and life could have been radically altered, or never emerged at all. Jupiter is, in that sense, a cosmic near-miss. It is a planet that almost became something fundamentally different. Its existence at just the right mass helped preserve the architecture of our solar system as we know it. Had it tipped the balance slightly further, our sky, and perhaps our existence, would be unrecognizable. Jupiter is not just a giant planet. It is a reminder of how delicate cosmic thresholds can shape the fate of entire worlds. The moons that change everything. Jupiter's moons are worlds of their own. Io is the most volcanically active body in the solar system. Europa hides a global ocean beneath its ice. Ganymede is larger than Mercury. Jupiter doesn't just break the rules as a planet. It commands an entire miniature solar system, each moon shaped by its massive gravity, each one potentially harboring secrets. Jupiter's existence may explain why our solar system looks the way it does. In many exoplanetary systems, giant planets migrate inward, destroying inner rocky worlds. Jupiter stayed far enough away. That stability may have allowed Earth to form. So when we ask if Jupiter is normal, we're asking the wrong question. Jupiter may be the reason anything here is normal at all. Jupiter bends space. It commands storms that defy time. It shields and possibly threatens our world. It is not just the largest planet. It is the most influential, and we are living in its shadow. If you want to explore more cosmic mysteries that challenge everything we think we know, subscribe and join the journey, because out there, the universe is far stranger than we ever imagined.